Hey guys, and we're back now for Igneous Rocks. Alright, so Igneous Rocks definitely are much different than sedimentary rocks in that these are of volcanic origin. Alright, so one thing that stands out right away are these little holes that are in the rock. Okay, so this is very common in igneous rocks because in that type of environment, just imagine bubbling lava or magma. Alright, so definitely more so lava because again the air bubbles are going to be released at the surface. Magma is actually cooling down slower, which we'll discuss the differences between those in a moment. So igneous rocks are rocks that form from cooling and solidification of molten rock. And remember, there are two different types of molten rock, which we'll go over in a moment. Often they have crystals because they cool, they solidify, and as they do so, they crystallize. So the minerals will turn into crystals. And this crystalline texture means they have a rock with intergrown mineral crystals in the sample. And magma is molten rock inside the earth, whereas lava is molten rock that has reached the Earth's surface. The main difference between these two is temperature. Magma is much hotter because it's below the Earth's surface, whereas lava has touched air on the surface, so it cools down quickly. Okay, environment where the molten rock cools determines the size of the mineral crystals. Okay, so intrusive igneous rocks form deep inside the earth because they're cooling very slowly. So think of all that rock material surrounding the rock. The heat doesn't escape as quickly, and it could take thousands of years, hundreds of years, thousands of years for these to actually slowly cool underground. And the result is large mineral crystals. All right, so cooling slowly makes bigger crystals. All right, and many of you have this in your kitchen, possibly granite countertop or gabbro, but they tend to call all countertops granite. All right, gabbro is just a darker color, but either way, they both have very large crystals. And large crystals, I'm talking about millimeters to centimeters. They are visible with your eyes, so they are able to be seen with your eyes, definitely. All right, clear as day. All right, extrusive, on the other hand, form at the Earth's surface. They cool very quickly. It'll take days to weeks to cool down. So you can see the difference big time. And as a result, cooling quickly, the crystals don't have time to grow. So small or no visible mineral crystals. So an example of that would be like basalt or obsidian. Okay, texture refers to the size of the mineral crystals. So coarse texture means there's large mineral crystals present, granite and gabbro. And fine texture is small but yet visible crystals present. All right, so basalt and rhyolite. Okay, and again, we'll see these on the chart in a little bit, where they're located and how it works. Okay, glassy texture, no visible crystals, does not mean it looks like a piece of glass, because I think of glass, I think of a clear thing that you look through. That's not the case with this. All right, it does have like a shine to it though. You can see there because there's no crystals to it. When water touches this material, it cools down extremely fast. That's why you get that look. So obsidian, and then also pumice. Pumice, again, you feel these kind of glassy pieces that are interlocking with each other. And also, coupled with that, you get vesicular gas pockets, which we'll talk about in a moment. So vesicular texture means there's gas pockets, gas holes in the rock, because again, bubbling lava on the Earth's surface, you tend to see this. So pumice, scoria. Again, the only difference between a lot of igneous rocks, they'll have similar characteristics. Coloring may be a difference, and also density, which we'll look at in a little bit. Okay, for igneous rocks, we're going to use texture and percent mineral composition, how much of a certain mineral is in it, And they did this in a kind of unique way, which we'll look at. Rocks on the right side tend to have high densities, whereas ones on the left side have low densities. Also, rocks on the right side are darker colored. Rocks on the left side are lighter colored. Okay, and let's see what this means. Okay, so on this chart, what they did, they kind of put all the rocks right here in the middle, and they scattered all the information around it. So the first breakdown is by environment of formation. So intrusive, plutonic, that's another word for intrusive. Extrusive, volcanic, just in case it comes up on a question. Also, if you go all the way across, the intrusive igneous rocks, they tend to have grain size that are on the larger size. So intrusive are 1 to 10 millimeters for the coarse texture, and also 10 millimeters or larger, they're considered very coarse texture. Okay, so those are large crystals, those two groupings there. So any of the rocks in these rows are larger crystal size. If you go up a little bit to the extrusive, these are again smaller crystals, less than 1 millimeter. Okay, so they're kind of microscopic. You'll only see them if you move them in the light slowly. You'll see a little shimmering. We call that fine texture. Okay, and if you go up to the top, non-crystalline, glassy texture. So these samples here, obsidian, pumice, basaltic glass, vesicular basaltic glass, are glassy, meaning no crystals present. Also, in this little row right here, these two rows are the ones that have vesicular gas pockets. So pumice, vesicular basaltic glass, vesicular rhyolite, vesicular andesite. This could be used in questions also in interchange with the crystals or glassy texture, so you can find your exact answers. Okay, to the middle part of the chart. So again, I said light colored on the left, low density on the left, and also they have the word felsic, which means it has silicon and aluminum. You'll see in parentheses there. Here it only says aluminum because it's the older version of the chart, but silicon and aluminum will be listed here, Si and Al. So the ones on this side have these characteristics. The ones in the middle kind of have a little mixture of both sides, so they just put them in the middle for that reason. And the ones on the right side here are all darker colored, high density, and they tend to be mafic, which means they're made of iron, Fe, and Mg, magnesium. Okay, so that's the middle part of the chart. So once again, they can throw that as a characteristic at you for when you're trying to figure out the names of the rocks. So you're going to think of rows and columns. So rows for this stuff up here, columns when you're dealing with the stuff on the bottom. Okay, so also on the bottom is mineral composition. There is a little scale here to show you percentages. You can play around and try to find exactly what the numbers are, but what I find the best thing to do is if they give you percentages, look what is the majority of the percentages, okay, and find what column matches up with that. So if they have a mineral that is, rock that is mostly the minerals potassium, feldspar, and quartz, right here, obviously you're going to end up in this left column. Okay, if you have, okay, the middle section is mostly plagioclase feldspar. All right, be careful because potassium feldspar is very close to that. All right, plagioclase feldspar and biotite and amphibole. So if it's mostly made of those three minerals, you have to be in the center here. There is a possibility of a little bit of quartz in there, but it's going to be very little percentage. And then this column, gabbro and salt and all those above, plagioclase feldspar can be a good percentage of that. Pyroxene is a big percentage usually, and then a little bit of biotite and amphibole mixed in. Okay, maybe even olivine. Okay, so this has a lot of minerals possibly listed in this, but look what the majority is. Again, that will place you in whatever column you're supposed to be. And the last column is pyroxene and olivine. mostly. All right, so you can see peridotite and dunite, which dunite is also almost 100% olivine. Okay, and peridotite is mostly olivine, a little pyroxene mixed in. All right, so that's pretty much it for this chart. Again, what you're going to do is you're going to mix match different characteristics and then figure out your answer from that. Okay, so thank you guys for tuning in. I'll see you next time.